trouble figuring out when it's compression and tension. Like, what's the difference?
Okay, so we're talking about trusses, right?
Yeah.
Let's say you have a truss like this. You have some loads, whatever, 3 newtons, 5 newtons. So when you start analyzing a truss, you do either the free body diagram to get the reactions, or if you have a joint that has only 2 unknowns, you can start right away. Like for example, in this case, joint A has only 2 unknowns, this one and this one. So we can start right away by joint A without the need of calculating any supports. You got that, right?
Yeah.
Okay, so let's go for joint A. So the free body the diagram of joint A will be a force going down here of 3 newtons, a force going away from the joint, and another force going away from the joint. Put always the forces that you don't know going away from the joint. If it's going away from the joint, means tension. Okay, so tension is pulling. So if I have a joint here, if I pull, that's tension going away from the joint. If I push, let's say this is the joint here. The joint here. If compression is pushing towards the joint, so this will be compression, and this will be tension, and this will be tension, right? That's the way to draw. Sorry.
How do you know when to decide?
Well, okay,
on the
let's
free body diagram?
okay, we are going how to decide. When you have an unknown like this, this is AB, this is AB, and this is AB. If you don't know what they are, you always put them in tension, like I have them there, going away from the joint, tension like this, right? If you don't know, you put it always in tension. So don't worry if you don't know. You don't have to know. You want to find the value of the forces on all these bars. Usually the problems in trusses is calculate the forces in all the bars, or calculate the force in bar CD. But you always have to calculate a force on a bar. So see, if you have to calculate it, it's because you don't know it. If you don't know it, then just put it in any direction you want. But actually, not you can put it in any direction you want, but the recommendation is put it always in tension like this. And then you do your calculations, and then you will find the value. If the value is positive, means the tension was correct. If it's negative, it's because it was compression. Okay?
It doesn't change the actual number value?
No, let's do it. Let's do an example. Let's do a little example real quick here.
With this example that you have,
I'm
having trouble at joint B.
In this example, the one that I have here,
yeah.
or this one?
Yeah, it's basically the same.
Oh, really? And the same loads?
No, but it's almost the same.
Okay, let's do this example. You want to do joint B? Because we have to do joint A before we can go to joint B. Yeah. Let's do this one. Doesn't matter. Let's put some angle here, because well, we need angles. Let's say we have this. Let's say this is a 3-4-5. So means are really easy. 3-4-5. Okay. All right. So this will be 3-4-5. Is okay the 3-4-5 for you?
Yeah.
Oh, okay. In this case, the easiest ways will be to go first for summation of forces in the y direction, right? You know why I do that?
Because you can get the value.
Because what?
You can get the value.
Because you can get the value right away, because in summation of forces in y, there is no component for this one. So this will not go into the equation. So you can get AD right away, right? If you go for summation of forces in the x direction, both forces have component in the x direction, so you will have one equation with two unknowns, which is not as good as having just one equation with one unknown. Okay, so we say summation of forces in the y direction equals to 0. Let's say you can do positive up or positive down, it doesn't matter. Let's do positive up, will be easiest here. So I have AB multiplied by what?
3/5.
3/5. And then what?
-3.
Minus 3 equals to 0, right?
Mhm.
Okay, so AB equals to 3 times 5/3, right? Equals to 5. Positive, right?
Yeah.
So I just found that AB is tension. So I can put here tension because I got positive. I automatically, without looking at the picture, I know that positive is tension because I assume tension and I got positive. So if I always assume positive, I mean tension, then if I get a positive, it's tension. If I get a negative, it's compression. So now let's do summation of forces in the x direction. Oh, okay, we don't need it because we are going for B, right? You want to talk about B?
Yeah.
Okay, in a real case, we will do summation of forces in the x direction also, but let's go quickly for B. So now our B will be the joint B here. Now we have the force AB. I got a tension, so it has to be, sorry. If I put joint B, then the force comes on this. This is the force that comes from bar AB, right? And I already know it, right?
Yeah.
And I know that is tension, so I have to put it going away from the joint. This is B. And then I have another force here, and I have another force here, right? AB, I know it already, so I can put AB equals to 5. And you don't put any sign, you just put a 5. Or you can put just the value. You can just put like this, just 5. Okay? If you put it like this, it's okay too. Now, BC, this will be BC. You don't know if this is tension or compression, so you put it in tension. BD, you don't know BD. So if you don't know BD, you just put it in tension. All right? And we do the equations. What will be a good equation here? A good equation will be again summation of forces in the y direction because you can solve for this one right away, right? Because BC doesn't have component in the y direction. So I'm gonna do positive going down here. It will be easiest. So I will say here we have the 3, 4, 5. And let's say that this one is also 3, 4, 5. So then we will have here 5 times 3/5 plus BD times 3/5, right?
Yeah.
Equals to 0. So then we solve here BD equals to, this go minus, right? Minus 5, 3/5 multiplied by 5/3, right? Agree?
Yeah.
So this will be equal to -5. Okay, negative compression. Automatically, you see a negative, then you put compression. All right? You want
What if
what?
what if on your free body diagram put BD facing the other way?
It will get the same answer, but that's not what we recommend to do. Let's do it here with the other convention. Let's say you do that this is B. This is what you got from the previous joint. It was a 5 in tension. And then we have here BC. And then we have here BD. And the same 3, 4, 5, right? 3, 4, 5, 3, 4, 5, and 3, 4, 5, 3, 4, 5. So here, summation of forces in the y direction equals to 0. I can put positive going up, positive going down. Anything you want is the same. Okay, let's do it here. Oh, you want this one in the other direction, right?
Yeah, BD.
You want BD like this, right? That's what you want?
Yeah.
Okay.
Yeah.
So summation of force in the y direction. Let's do, you want to do positive down or positive up?
Down.
Down, positive. Okay, perfect. Then 5 multiplied by 3 over 5. BD is going up. The component in the y direction of BD is going up. So it will be negative, right?
Yeah.
So negative BD times 3 over 5, right? 3 over 5 equals to 0, right?
Yeah.
Okay, so then from here we can solve for BD. BD equals, this is negative, right? So if I put positive here, is like I put it, let me do it like this so we don't get confused here. So I have here minus BD 3 over 5 equals to 5 goes to the other side with negative, right?
Yeah.
So now I can multiply by -1 in both sides, and so I get positive and positive, right?
Mm-hmm.
So now I got BD equals 5, 3 over 5, and 3 over 5 goes 5 over 3, right? And this is equal to 5. Positive, right?
Yeah.
What this positive means?
That is tension.
No, that
No?
positive means that what you assume here was correct.
Oh.
That's the meaning of this sign here, same as here. In here, this minus sign means that this assumption here was not correct, so it was in the other direction. When you assume here that this is compression and then you get a positive sign means that your assumption here was correct, so it was compression, you were right, right? But then doing it this way, as soon as you get the answer, you have to go back to your joint to see what you did and check if the assumption was correct or you have to fix it, right? So that is why we don't like this way to do things, because you have to go back and check what you assume at the beginning and then take the right direction. If you put it always in tension, as soon as you get the result, you see the sign and you see positive is tension, negative is compression, and you don't have to look at your drawing. It's more automatic like this. Okay.
No, yeah, it makes sense now.
All right. That's the reason why we always recommend put unknowns in tension, which is positive. As soon as you get a negative, you know it's compression automatically.
Okay.
So do that all the time. It doesn't matter if you know, no, I know this bar is compression. I know. It doesn't matter. Put attention so at the end, the result will be negative. And it's very, very consistent, very consistent. I see a student, when you get this, a bar like this and a bar like this, let's say this is A, B, C, and you have a load here like 100 newtons. I see the students always do like this, it's 100 newtons. And then they put this one in compression because they know this is compression, but CB is very easy to see that that bar has to be compression, and this one will be AB. Doesn't matter that you know that this is compression. The recommendation is always put unknowns in tension, always in tension. As soon as you solve this, you get that CB equals minus 50. Oh, okay, compression. All right.
Okay.
Don't
that helped
fall.
a lot.
Sorry.
That helped a lot.
Yeah. Don't fall into the temptation of putting an unknown in compression. Don't fall into that temptation. It's sometimes, no, but I know this is compression. It's not the same for the reactions. Like here, you have the reactions here. And the reactions do whatever you want, because then you have here your free body diagram, whatever, and then you have to put here, you put here a force like this, a force like this, a force like this. Put anything you want, right? If you don't know what it is, you put it in the direction that any direction. You don't spend time trying to figure out, unless you are really sure that this is going to be to the right, to the left. The supports are not tension or compression. The supports just have a direction. That's it. And at the end, when you calculate the reactions, if you get a positive sign and when you get your answer, then you say, okay, it was correct. If you get suppose you are calculating this force and you get a negative sign, and then you say, oh, that was wrong. So this is actually in the other direction. Okay.
Okay.
That's the same thing for any problem in statics. All right.
Okay.
That was it. Anything else?
Yeah, that was it for now.
All right, yeah, no, just call me anytime. Don't worry. I'll be working here for a little more while probably. If I don't answer it, I already fall asleep. But if I'm working, I don't mind just taking your calls.
You go to campus today?
Yes, I just arrived.
Oh,
It's so far. And then after I finished, a guy wanted to talk about the stuff, so I stayed talking for a while, and then I stopped on the grocery store for some stuff for breakfast, and I just arrived. I just arrived when I called you.
okay.
Okay,
Thank you very much.
you're welcome. You just text me, and if I see the text and I am awake, I answer it. If not, I call you back or I reply your text the next day.
Okay.
All right.
Thank you.
Have a good one.
Have a good night.
You too. Bye-bye. Thank you.